We'll make a start, and first off I'd like to welcome everyone to our first Soils Network of Knowledge webinar for 2021, and I'd like to introduce this month's speaker, Justine Cox. And Justine's been evaluating different biochars and composts for over the last 10 years in a range of horticultural crops and soils. Over her career in soil science, Justine has contributed to projects investigating soil health in vegetables, biological indicators, mulch performance in blueberries, compost and biochar soil amendments in blueberry production, root physiology of macadamias, and soil erosion control in macadamias. So Justine's evaluated the impacts of compost and biochar on soil carbon and greenhouse gas emissions in banana, blueberry and melon production, and is currently collaborating on the Clean Coastal Catchment Project, which aims to reduce soil and nutrient loss from macadamia orchards and blueberry substrate production in the Northern Rivers region of New South Wales. And today she's going to talk about biochar and compost soil amendments in horticulture production, so she's well placed to do that, and short and longer term impacts.
Thanks, Abby, and thanks everyone for turning up. I would like to just go over some of the work I've been doing on biochar and compost in horticulture, based up here in the north coast of New South Wales in the Soil and Water R&D unit. So let's go straight in and talk about compost. Compost has multiple benefits, but as you realise, compost batches are very different and very variable. So here's an overview of some of the benefits that you might get from a compost. You can get soil surface protection, and so in erosion control, increases soil moisture retention. It can add organic carbon to the soil and improve soil structure. And as a source of plant nutrients, slow release nutrients and macro, micro, and a source of microbes. But as I said, not all composts are going to give you all of those benefits. So we start looking into compost as fit for purpose. So what do we want to use compost for? And we also need to reapply compost because it degrades and decomposes over time. So let's talk about fit for purpose. So I work a lot in tree crops. And so often we want to compost as a soil surface protection, as a mulch. And we're interested in soil structure improvements. So for this purpose, you might look for a compost that is high in carbon to nitrogen, that ratio. And so we're looking for a woody compost, lots of plant material with a large particle size so that it allows water to pass through and slowly decomposes. So it would be placed on the surface, probably at a fairly high rate so that it would retain on the surface for a while. If we compare that to, say, a vegetable crop, and maybe a grower wants to use compost to actually provide nutrition and especially nitrogen for a crop, and so we're looking for a very different compost. So we're looking for a slow release nitrogen supply, say for vegetable production. We'd need the compost to be fairly high in nitrogen, and it's likely to then be a manure-based compost. And it'd have to be very small particle size, it'd have to be screened, and you'd usually incorporate that into the soil. So it needs to be reapplied because it decomposes over time. So this is why I wanted to introduce also biochar. Biochar, what is biochar? It's a charcoal-like material and it's very high in stable carbon. In fact, it can have retain its carbon for hundreds and hundreds of years in the soil. And it's created by heating biomass. And so that's anything that was living, plant or animal material, often agricultural waste products. From that range of, say, 350 to 700 degrees, under no oxygen conditions or very low oxygen conditions. This is called pyrolysis. And this is a process, we don't want to create carbon dioxide and a greenhouse gas. So in this process, the properties of the biochar can be very variable like compost, and it's very much influenced by what it started out as, if it's manure-based or if it's plant-based, and the maximum temperature it got to. So that range has a very important impact on its final properties. The pressure it was under, and then the particle size, again, that it comes out, it can be very fine and powdery or very big and chunky. So the properties of biochar, which we're interested in is a very porous structure. As you can see on this picture on the bottom right-hand corner, it's a scanning electron microscope picture of biochar. You can see a lot of holes, and this is it's a very porous structure, which means it has a very high surface area. And these holes are actually original tubes that come from the plant material that it is based on, so phloem and xylem tubes. It's often alkaline pH, so you can have a pH of 8, 9, and 10, and it can have negative charge. So I often describe it as like one of those really big chunky sponges with lots of holes, lots of gaps, and lots of surfaces. And it's important, those properties then dictate a lot of its properties in soil. So we see quite a range of benefits of biochar when applied into the soil because of its properties. And we've been looking at studying biochar for only the last sort of 15 years. But what we find is increases soil pH. And that's particularly important, especially in acidic soils. It's very has a liming capacity. And so in acidic soils, this can really improve nutrient availability because nutrients have a range of pH where they're most available. And in very acidic soils, it can reduce aluminium and manganese toxicities when they're very high. And so that overcomes a very limiting factor in some of these acidic soils. And improve soil moisture retention. All of those surfaces and pores actually hold more water, and so therefore making soil moisture in the soil higher. Increase nutrient retention and cycling, especially nitrogen, and this has been one of its major benefits in soils. But we find it's only with added fertiliser. So by itself, it does not have any nitrogen that's freely available, but with fertiliser, it makes that mineral fertiliser retained on those surfaces, but available to plant roots to uptake. And it's also shown to reduce like nitrate leaching and phosphate leaching in lots of occasions. And reduce greenhouse gas emissions like nitrous oxide. So there's a lot of information in the nitrogen story that we're trying to find how biochar fits in. And again, not all biochars will do all of these things. It depends on their properties. And we see biochar used a lot in soil carbon sequestration, especially the biochars that are created at a very high temperature. They're very stable, and they will stay in the soil and maintain their carbon. So if we look at all of the studies that have been published in biochar, there's a lot, and there's a big range, as you can imagine. But we wanted there's been a meta-analysis undertaken to see if there's any overall trends we can see that come out of all of the data. And so on average, looking at all of the data, there's an 11% yield increase when biochar is used in soil. Okay, so you can imagine the range is from detrimental to many hundreds of percent increases, but on average, there is actually a positive benefit in yield. And so that's there's an interest in using this amendment. But there's a strong affinity with increased effect with fertiliser, and that can be inorganic or organic. And looking at the conditions where biochar is most effective, we're finding out that it's most effective in like tropical environments, acidic soils, low nutrient soils, and sandy and coarse textured soils. So soils that are limited in this way are very likely to improve with biochar amendments. That's not to say other climates and other soils won't be responsive, but just looking at the data we have so far. So there's been a lot of recent interest in biochar and compost together because of this affinity that biochar has retained nutrients. And so there have been studies that look at the synergy between biochar and compost, in that studies that have tried to look at the combination of this, compare it to their individual improvements, they're finding that there is actually, the combination is greater than the sum of its parts. So there's something in that combination that is showing greater improvements in crop yields, in soil pH, nutrient retention and plant uptake, and especially nitrogen, phosphorus and potassium, and increased root volume. So there are some changes in the soil structure and chemistry that is really, plants are really utilising. We don't know exactly all of the mechanisms why, but there's been a recent sort of attempt to study the surfaces and to come up with a mechanism. And a group have come up with that there is they found an organic coating on the surface of biochar. All those surfaces seem to be coated with organic layer, which then improves that nutrient retention availability, and especially nitrogen. So there's definitely interest in that, and there are many papers coming out in the last few years looking at this combination. I would just like to go through some research that I've been doing in this district and around the country, just to show what we've been finding. So this case study, I looked at blueberries up in the northern rivers. We have a red aggregated clay, which means it has a good infiltration rate, so it doesn't get waterlogged too often. So this experiment the objective was to look at different ways we could use waste material, so green waste and sugarcane trash. And this company and business were thinking about whether to go with composting or biochar. And so compared a number of different biochar mechanisms and methods, and looked at compost and then the combination. So we have a green waste char. The first one is their slow pyrolysis, and it was 550 degrees. And this second one was exactly the same material, but was pyrolyzed fast at 4 minutes, and they didn't have as much control over the temperature, but a similar kind of temperature. Sugarcane trash char was also a rapid but a fairly higher temperature, and a green waste compost, and the green waste compost and sugarcane trash biochar, and compared that to the control. And all of these plots were fertilised with the farmer's normal fertigation. So what do we find? So this trial, we established at the end of 2011, and you can see right at the start, we're looking at soil organic carbon, and that includes all that stable carbon and also the labile freely available carbon. So if we look at this graph, we're looking at organic carbon on the vertical axis. So the control is this dark blue down the bottom. We're starting just under 4% carbon, and all of the amendments increased carbon right at the start. And so right at the top, we've got that combination providing the highest soil carbon. Okay, so after the first summer, we've got most of the amendments had the carbon in that soil had decreased, and we would expect that in that all of the free available carbon would be decomposed, releases carbon dioxide, and so that's a lot in the compost, but also there's a amount of a very small amount of labile carbon associated with biochar. Okay, so then after summer, we have a growth period, we have the plants growing, and we have roots contributing to the carbon in the soil, and the plants flower and fruit and go across their life cycle over the year. And we get to the December 2014, where the trial ended, and we find at the end of this trial that the combination and also this green waste biochar here was still higher than the control after 3 years. So we have some longer term effects still for this combination. If we now look at the pH of the soil, which is important for nutrient availability, we can see back at the start at establishment, the control down the bottom was just under 6 pH, and then we've got only slight increases of pH at the start for the amendments. And over the long term, its pH declines over time, which is what we expect with the use of fertigated nutrients and this environment up here in the subtropics. And so at the end of the experiment, 3 years later, all of the pHs are statistically similar. So the effect of the amendments are sort of reduced by the end of 3 years. So we look at yield, at blueberry yield, and we studied this for 3 years after they matured. So the first year here, this is grams per plant. The first year that they yielded, we got very excited, and look at this, with the combination was substantially higher than all of the rest of the amendments. But then the next year they were all the same, and the next year where we had a bigger crop, they were still all the same. So there's no impact on yield except for that first year. So now I want to talk about another case study, which is called the Fruit Salad Project. And the objective of this project was to look at compost and biochar in terms of their carbon sequestration potential and also reducing greenhouse gases, but also to look at the impacts on the production. In this trial, all of the treatments were put at 4 tonnes of carbon per hectare, and that was so all they had the same amount of carbon applied, so it was standardised, and that was just in a banded application. So we have the control with no amendments. And the compost here was a poultry manure and crop residue, so it had an amount of nutrient in it. Biochar was a poultry manure biochar on the low end of the temperature range, and the combination of one-to-one to biochar and compost. It was called fruit salad because we had 2 banana sites, 2 melon sites, and a blueberry site. So I can't give you all the data, so let's just have a bit of a snapshot. Here's the melons I'll show you. We've got Bundaberg in Queensland was a loamy sand soil, and in Griffith, the New South Wales, a silty loam. And the rates of 4 tonne of carbon only was 8 tonne of biochar per hectare, and compost was 25 tonne a hectare. So not very high amounts. So let's have a look at the impact of these amendments on total organic carbon. This is in the 0 to 10 centimetre fraction, where it was incorporated. So here's percent carbon on the vertical axis, and we're at about just under 0.8 for control. And we didn't really pick up any increase straight after establishment. And a year down the track, all of the amendments were higher than the control. Okay, so we have that that combination, the biochar and the compost, all at the same level. And then after a year, after that, so year 2, we find no difference between any of the treatments. So all of those amendments were just the same as control. If we look at the pH, we've got that kick of all of the amendments actually increasing pH at the start. But then after 1 year, that's not different, and after 2 years, it's not different. You can see that the pH in this soil is actually quite low, and so this increase here would actually be quite useful in providing nutrients availability, increasing the nutrient availability. So let's have a look at yield at this site. We did a lot of yield sampling. So the first year, so fairly soon after the amendments went on, so 3 months, there was no impact on melon weight of the amendments. But we measured a lot of quality measurements to see if that was improving, and we found every amendment actually improved melon quality, and some of that was bricks, and some of those made the bricks high enough to reach the standard that the supermarkets were requiring. The second crop went in was zucchinis, and there was actually a significant increase in yield in the zucchinis for all of the amendments. So biochar went up 13%, compost 9%, and the combination 11%. And the quality of the zucchinis in the biochar were significantly higher than the control. So the next crop after that was the melons again, and no significant impact on yield, but again some quality measures were significantly higher in that combination and the compost. So we often find we can't pick up yield responses just to variability and the amounts that we're putting on, but some are finding a lot of quality issues are improving. I just want to touch on incorporated versus surface applied amendments, because this is an issue for me, especially working with macadamias and other tree crops. You can't incorporate these amendments because especially macadamias, the surface roots are very active and very high in the profile, and so you can't dig amendments in. Most of the research is done in this area is in incorporated amendments, and so in incorporation you get a lot of contact between the material and soil particles and the roots. So I was interested in the question, well, if you can't incorporate and get that, when you get applied on the surface, do you get the same benefits from the amendments, and do they penetrate into the soil to depth? So I've recently studied that question in Hawaii, doing my master's on this question in a pot trial. And I had a biochar and compost combination and looked at a couple of different plants. So bok choy to represent sort of annual crops, which you would normally incorporate, and a longer term tree crop, a papaya, to represent the tree crops that you would put on the surface. So here was my my treatments. Control was just normal fertilizer. Incorporated was down to 10 centimeters depths, and these pots were 20 centimeters deep. And I'd surface apply on the surface, and the rates that this worked out to be: biochar 15 tonne a hectare and compost 26 tonne a hectare. Biochar was plant wood based, and the compost was a chicken manure based compost. So straight to some results. We're looking at the yield here, and this is the Chinese cabbage, or the bok choy. We're looking on the vertical axis, the dry weight, so the biomass, how much the bok choy weighed dry. And here's two trials which just were done in different seasons. So the controls, so if we look at the blue bars, the control, so both incorporated and surface applied amendments increased the biomass significantly than the control. And when I did it again, the green bars got the same result, and the incorporated and biochar, incorporated and surface applied were significantly similar. So they were just as effective whether it was incorporated or surface applied. So in this case, the amendments were highly beneficial to yield. And I got a similar response to papaya. And in fact, the surface applied amendments actually were even better than incorporated for papaya. So in this really short-term study, we found that soil nutrients sort of moved down the profile. So here's my pot over on the left in brown. Here's that 0 to 10 where it was incorporated or put on the surface, and here's the 10 to 20 which I measured as well. So if we look at the first one, the incorporated results, here's all the nutrients that were higher than the control at the end of the harvest. So total carbon was higher, total nitrogen was higher, nitrate, phosphorus, calcium, magnesium, and sodium. All of those extra nutrients were higher in that 0 to 10. But also when underneath where it was incorporated was still higher in total carbon, calcium, magnesium, and sodium. So this would have been movement of dissolved carbon through the profile, maybe even movement of particulate carbon, and also a little bit of root exudate contributions. So over here on the surface on the right, it was applied right at this surface level here, and so we found when we measured the 0 to 10 centimetres below, we still got a higher total carbon, phosphorus, potassium, calcium, magnesium, and sodium in that 0 to 10. So those, when we watered those plants, all of the dissolved fraction was moving through and getting picked up in that 0 to 10. What we even found is that in the 10 to 20 centimetres, so 20 centimetres below where it was applied, an increase in phosphorus, magnesium, and sodium. So these nutrients we're getting through. So that's some short-term and long-term experiments. So I'll just wrap it up quickly at the end. So biochar increases soil pH and retains compost nutrients in the soil, making it more available for plant uptake. So that combination really does do a 1-2 punch. And the biochar and compost often outperform a single application. However, long-term monitoring is required as the effect reduces over time in the field. And so there's a lot of more monitoring and longer-term trials to see the impacts of these amendments. And I'll leave it there. Thanks. Just the acknowledgements for all the people who are involved in the projects.
Thank you, Justine. That was really great. And now, as I said before, we have time for questions. Carol Rose says, 8 tonne of biochar is a low rate. What sort of cost? And is the increase economic after this?
That's a good question, Carol. I think the cost biochar I was getting it for $800 a tonne back then. It's expensive, and because the yield increases are not major, then as on just pure economics, it's not something you would run out to get right now because of the economics. We need to be able to sort of look at the other value of the improvements and look at that long term to see if they're cost effective. Yeah. It may be more important in areas where water is limited because the water improvements are quite substantial, water retention. If you're on limited water or an irrigation system, which you can reduce irrigations. Yeah, I concentrate on a few things, but yeah, it's not something that you would run out without sort of doing some sums and working out whether it was effective.
Yeah, okay, Lucas has just made a comment further to that because, so everyone, Lucas Van Sweeten's also participating in today's webinar, and he's a researcher here at New South Wales DPO and has done quite a lot of work on biochar as well. And he has said that biochar producers are looking to make it available at $100 per tonne, depending on the nutrient content. And if it's obviously got more nutrient, it would be worth more. And then Carol's also added to her question about, will it pay if it's part of a carbon credit program? And I guess, you know, who knows? It may. That's sort of out of our control.
Yeah, there's definitely interest in more in the carbon credit space, depending on how much carbon credits are going for. But it'll definitely be there long term, and it's quite an effective way of transferring sort of material into the soil where it can be safe and permanent.
All right, our next question is from Lucas, and he said, is the combination benefit due to additive effects? That is there more nutrient added, and it's a simple calculation like that?
I think it's more than that, because the nutrient from the compost and the impact of that, and then the impact of the biochar, when you add those impacts, the effects of plants together, the combination is even higher. So I think that when the compost decomposes and that organic nitrogen gets converted to mineral nitrogen, that mineral nitrogen, it is attached to the biochar and then but made available to the plants, and so that you're having very highly efficient nitrogen use, and other nutrients as well. So you're getting very high nutrient use efficiency.
So there's a few questions about how it could be, or is it commercially available to various industries, and what you would look for if you were looking to get some in terms of quality. What are the points you would look at?
There in the chat is the link to the International Biochar Initiative. And they've got a lot of resources which address that question about quality and what you would what manufacturers are testing for around the world. It's I'm not quite sure about the availability in Australia. I haven't sort of bought biochar for quite a while now, so I don't know its current availability. There are I've seen compost manufacturers adding biochar into their product at sometimes 10% sort of rate. So that's what I'm seeing more. Maybe Lucas, you might know more about the commercial availability. There are companies that are supplying sort of smaller quantities. Yeah, I think if you're wanting for carbon sequestration, you go for a high temperature biochar.
It goes back to the point that you made at the beginning, I think, Justine, too. It's about fit for purpose. So you have to look at it with that, with those goggles
cost.
on as well. Yeah.
Yeah, cost, and then how you would apply it, because it's not something that's easily applied by itself. It's very lightweight for its mass, and so it can be very dusty and very hard to apply. You wouldn't put it on the ground and leave it. So it needs to be either in a pellet form or in a combination form, or with something else. And so there are fertilizer companies working on ways to incorporate a little bit of biochar in some of their fertilizer pellets.
I might just unmute Lucas, if that's possible. Lucas, we'll give that a go and see if you have anything to add. You actually self-muted, so you have to. There you are. You're on. Go for it.
Thank you, Abby. Thanks, Justine. So you just wanted me to provide a bit more information on some of the commercial availabilities. So there are a range of medium-scale projects currently in Australia where they are producing biochar. Some of that biochar is ending up in animal feeds, and there's some great examples of that in northern New South Wales. There's a really interesting project that was on, I think it was Landline last year. That's a rainbow bee eater project at Mount Gambier, and that's where they're taking waste wood out of Melbourne. They're pyrolysing that waste wood for production of carbon dioxide for a big glasshouse facility that's producing herbs, and then they're using the surplus energy in that process for making electricity, again for the lighting, I think, or for putting back into the grid at that glasshouse facility. So they're getting a lot of bioenergy outputs, and they're looking at supplying that composting quite cheaply via a compost company in Mount Gambier as well, a fairly large compost company. There are also some projects in Tamworth where they're looking at woody weeds, waste timber, and also perhaps some animal manure projects. So the commercial availability is on the horizon. It is starting to become commercially available now. And there are a few administrative and legislative hurdles with regards to application of waste to land that still need to be sorted out, but it's getting very close, I think.
Thanks, Lucas. That was really useful information. There is Andrew Gulliver's just asked you to run through the take-home messages again, Justine. So if you do that, that would be good.
Just to put them back up, or just to elaborate?
Yes, maybe we'll just put them back up there, and if Andrew can read them, if you want some more detail about that, just send another message, Andrew. And while we're waiting for that, we'll go on to another question from David Prim. He says, you mentioned biochar enabled lower carbon emissions. What is the total carbon budget when including the production of the biochar? So that's like a full LCA, I'm assuming, what he's asking.
Yeah, depending on the process, the production of biochar and then using that into soil is actually carbon negative. So it's actually taking carbon out of not the equation, but it's actually a beneficial to greenhouse gas emission accounting. So the biochar manufacturers are very keen not to contribute to greenhouse gas emissions. So the process doesn't emit carbon dioxide, and when it's used into soil, it then stores that carbon. So there's a lot of interest in its its role in reducing greenhouse gas emissions for the country.
And I think, David, if you're interested in how that happens and the process and how they do that, the International Biochar Initiative site is probably a good one for you to look at, because they run through how it works and how they're able to do that and things like that. Jose has asked, in the soil carbon trial, when you applied 30 tons of amendment, after calculations from 4.5 to 7% increase in carbon soil content, the carbon content increases to 65. How can you explain the difference between the 35? I think he means 30 to 65 increase.
I'm not sure I understand the question.
So I think he's saying when you only apply 4.5 to 7% increase, how do you get what with? Yeah, maybe he needs to could you rephrase that, Jose, so it's easier for us to understand what you want? I think he's saying the calculation isn't making sense to him, but we'll just.
Oh, okay.
Are there any? Well, I'll wait for Jose to just clarify that. Lee Trevitt said, are there any plans for proposals in development for technical quality guideline or standards, like the amendment one for compost and things like that? Are you aware of anything like that, Justine?
I would imagine so. There's in the International Biochar Initiative, there's standards for testing and quality depending on use. So yeah, there will be more guidelines. There's also an Australian New Zealand biochar group working sort of more locally. They have a website too. It's ANZ BIG, ANZ BIG.
Okay, great, thank you. Andrew Gulliver's asked if biochar or compost holds on to the soluble N, e.g. the ammonium nitrate.
Yes, temporarily. I would imagine, yeah, it does.
Okay, thank you. And then there's a few comments from people around other questions that have already been asked, which is great. Thank you very much for this. So Don Coyne said Puro is a voluntary carbon removal marketplace, which is attracting approximately $100 per tonne for char. And then Lucas has said that there is a program in California for carbon credits from biochar. So if people wanted to follow up that, they're also good leads. Steve Kimber says early economic analysis showed carbon credits were only a small piece of the pie and production benefits were worth much more. So that's interesting. Comment on the economics from Steve Kimber, who's also a researcher here at New South Wales DPI. And Don Coyne has also said there's approximately 5,000 tonnes of biochar sold in Australia, conservative estimate. And what else? Animal feed and using dung beetles is a popular way to apply it. So that's interesting. Just trying to see if there's any clarification on those other. Yeah, the question that Jose posed around the increase in carbon, he's querying the maths, so that's what he's saying. So if you could go back over that, Justine, if you need to change the slide, that might help.
Yep. Which one would that be? That's
just looking at his first question.
The first one, that one?
It's where you show between a 4.5 and a 7% increase in carbon in the soil, and increases to 65 megatons. Is that, did you have a?
No, I didn't have a megaton unit, so it's all percent. Yeah.
Okay, perhaps
so
that's the issue.
I would imagine that increase in carbon relates to root exudators and roots in this, and also additional sort of process of like stabilizing some of the compost carbon.
So what you're saying is the increase in carbon is not all just that you've added extra carbon from the biochar, something else is happening to help you
a
capture
little,
the
and there's
carbon.
variability in these numbers too. So
Yep.
Yep.
Okay.
The other thing is there's a lot of interest in using biochar for pollution control and waterways. It actually absorbs quite a number of chemicals, so there's a lot of uses for it in pollution cleanup.
Yeah, mopping up stuff. Yep. Rakesh Awale has said, in one of your studies, all biochar and compost amendments increased pH over the control in year 1. However, there were pH increments in all treatments, including the control by year 3. Why do you think pH in the control increased over time?
I would imagine the farmers would have limed it during the seasons. Most of the growers that I'm working with are very much aware of their pH and would lime to get that pH back up.
Yeah. Okay, thank you. And Nico Halloran has asked if there's some data that you have to support the increase in soil water holding capacity, either potential PAWC or RAWC, readily available. Have you?
I didn't show any of the water data, but yeah, I do. We have got water sensors in some of the moisture sensors in some of the trials here, yeah.
So Nick, you could contact me to get in contact with Justine or contact Justine directly about that if you wanted to sort of further that. Carl Anderson has a question and says, organic carbon seems to fluctuate a bit over the few years of the 2 case studies. Any thoughts on why?
That's a lot of variability and a lot of sampling error, and then on top of that is the stages of the plants and whether they were plants in the ground at the time. But yeah, carbon does bounce around a lot over time. And especially in the disturbed sort of highly sort of changing systems I've been working with, so mounded blueberries and mounded sort of melons, when the mounds get created, there is incredible diversity in just a very short amount of space. So spatial variability is high.
Yeah, okay, thank you. So that's a function of the farming system to an extent. Thank you. Thanks for the question, Carl. Oh, and there's another bit to it. And do you have the confidence intervals for the organic carbon in the case study 1, as in were they different? Maybe Carl can contact you directly about that.
Yeah, I didn't put all the error bars in the presentation for today just because it gets really messy.
Messy, yeah. Yep, fair enough, yep. This might be another question also for Lucas from Carol the production of biochar. She wants to know if any waste facilities are interested in that. Could cities subsidise farmer use, or are there toxicity issues?
I actually think that'd be quite a good question for Don Coyne. I understand that there's a council on the Gold Coast currently, and I think one in Victoria currently looking at pyrolysis plants for their municipal waste, including biosolids. So yes, there is interest in local council for utilising these facilities for waste management and energy production.
Yeah. Okay. Thanks, Lucas. I'm going to unmuted. You're self-muted, Don. If you wanted to add to that, that would be great.
Yes, thanks, Lucas and Abigail, and thanks, Justine, for a great presentation. So, yeah, just to add to that, one of the first municipal council projects that happened worldwide was actually in Stockholm, in Sweden, and it received a philanthropic grant from Bloomberg, actually. And that project has, sparked interest with other councils around the world, including Australia and New Zealand. And yes, to confirm that Logan City Council has now got through to the testing phase of the first biosolids gasification plant, and that was commissioned by Biochar. So I do understand, I don't know for sure, but I do understand they are now, that was a test pilot, and they are now commissioning the actual larger scale system there. And also in Glenelg Shire Council in Victoria, they are looking at heating their council facilities, swimming pools and community centre with a pyrolysis system. So they have like a European style district heating. So they're looking at that, and I think I understand they've sort of secured a offtake agreement for providers of the biomass and then the to take the biochar and the wood vinegar. Also, Collie in WA, another company there, Renergy, has just been successful in a renewable fuel type project that has biochar as a byproduct. So they produce like a pyrolysis oil, which can be used in biodiesel. And look, and also, operating for probably the last 5 years is the Green Man Char people, who are at the Manningham Council. They're at the Templestowe landfill site, so they've been producing biochar and wood vinegar from municipal green waste down there a number of years. So
Okay.
it's starting to happen. It's very exciting.
It is. It's really exciting. Thank you for that, Don. And just for everyone else, to let everyone know, Don is from Byron Biochar and also a director at the ANZ Biochar Industry Group. That's correct, isn't it, Don?
Correct. Yeah.
Yep.
Ansbig.org. Yeah.
Yep.
For more
Okay.
information. Thank you.
Yeah, which is Justine mentioned
Charles.
and speak before. So thank you for
Charles.
that insight. That's great.
Yeah, the first case study I showed was actually Brisbane Council were the ones interested. So they've been interested in Queensland for a while. So it takes probably a number of these kind of projects to get them confident that it's a worthwhile process, and they're seeing that sort of develop now.
Yeah, it is. It's really exciting, as Don said. This is a very long bit of text from Neil Hinchy. When producing pyroligneous acid from vegetation, the timber type affects the performance significantly. That is, bamboo is different to eucalyptus, another conifer, whatever wood. And putting aside the nutrient content, to what degree does the species and category type of vegetation feedstock used to create biochar affect its performance and stability?
I don't think I have the knowledge to be able to answer
Are you
that.
up for that?
No, that's quite. Yeah, looking at the different species and its effects, I'd have to look up some literature to see what.
Yeah.
So I haven't had the experience in sort of looking at that in detail. Sorry
Yeah.
about that.
Yeah, because we're not in the business of making the biochar, but more seeing it, what its application is to soils and agriculture. Victoria Brunn has asked, is there a percent level that is better? I ask this because we sell a carbon product that is 28% carbon, so I'm wondering how this would compare to the percent of carbon in biochar.
Biochar, the ones that we've been using have been around 50% carbon. They range a bit depending on the temperature it was created at. So, but they have very different sort of profiles in terms of how long that they last in the soil. So they're not directly comparable, but when you analyse the biochars, it comes out about 50 to 80% carbon.
And again, it was to be about fit for purpose, if you in your choice of what to use, I guess. Yeah.
Yeah. So when you put compost on, you want that carbon to decompose, and that's the point, is so that you're releasing sort of slow release, small amounts of nutrients, but also getting those particles into the soil, and so you want it to decompose, but then you need to sort of reapply.
Yeah. Lee Trevitt has said, are soil analysis laboratories generally aware of using biochar as part of soil conditioning recommendations? Good question.
Yeah, probably some more than others, I would imagine. Some that's had exposure to analysing biochar, like we have a lab on site here for the state lab, and they've analysed biochar now for a while, so they've made sure that their procedures sort of make sure that they collect all of the it's appropriate for biochar.
I guess as it increases and people's interest increase, that will filter into what good labs recommend, or agronomists, private advisors, that sort of thing.
Yeah.
Michael Rowe has said, does the stable carbon in the biochar continue to provide a surface for retention of nutrients long term when further compost, etc., is added past the 2 or 3 year point? That's great. So is there like a full point?
That's a really good question, and I think there is a full point to that all the pores and all of the surfaces get sort of, what's the word?
Used.
Yeah, then there is no more sort of surface available. And so there's a lot of interest in this particular area in longevity of those pores. And so, yeah, I think there is a fill point. And so what that means, it might mean you have a less of effect over time.
Yep. Carol Rose has asked another question. Does biochar make nitrogen more stable, so less nitrous oxide losses? Is that what's happening?
I don't know about more stable, but we often find, yes, less nitrous oxide is released in the soil. So either it's reduced production in the first place.
Yep.
Yeah. I can talk to Carol about that, or maybe with Lucas as well, because it's a quite detailed sort of process.
There's also a nice reference. Oh, whoops, I've just lost my control panel. There's a reference here that Lucas has given us very kindly, which I will try and put in the comments in a minute, but it's Nature Climate Change 2017. And it's about increasing soil carbon via biochar plus the priming effect that it might have by Weng et al. I don't know if Han is still online, but that's a good reference. So Steve's also suggested that paper. Yep, and so there's a role of stabilising carbon by the rhizo deposits, which you kind of mentioned, Justine, which is outlined in that paper, I think. I'm just looking through. Carol Rose, can't believe you went all the way to Hawaii just to do a pot trial.
I know, right?
Nico Halloran has said, can you get both energy production and biochar production, or is there a trade-off in the yields of either?
I think that's beyond my...
Yeah, my understanding is that you can do both, but I don't know if Don or Lucas want to comment on that.
Would you like me to comment on it, Abby?
Yeah, why not?
Everything's a compromise. So, yep, more energy, less biochar. But some of the nutrients will be then retained and concentrated within the biochar. So, for example, phosphorus will end up concentrating within biochar. Nitrogen, you tend to get some losses. So it all depends on which nutrient, but certainly with the carbon, the hotter you run the pyrolysis or the longer you run the pyrolysis, the more energy you get from it, but the lower the biochar yield.
Yep, got it. Makes sense. Don's also said that Microsoft has included ANZ biochar in a mix as part of their carbon removal methods to help them reach their carbon negativity by 2030. And Lucas has just added an extra comment to whether you get to the full point in your biochar. Pores are dynamic and they're continually reactive with new carbon and forming microaggregates even after 10 years. So I guess we're still waiting to see what will happen in that sphere in terms of our observations, given that biochar is a relatively new product. And Andrew Gulliver has said, any observations on the performance of carbon in a highly humified compost versus less mature compost? It's a good question. Is it reasonable to assume that high humus compost will last longer in soil and behave more like a biochar?
I haven't done that comparison. It's a really good question. I could imagine that a high humic compost would actually last longer.
Yep. I think I have got all the questions. one more. Carol's snuck one more in. Any info on biochar and herbicides? That's a good question, given that it can hold on to stuff in the soil.
Yeah, there's been a paper that shows it's reduced the effectiveness of herbicides because it holds on to the herbicide and therefore is less dose in the soil and to the plant. So it's actually reduced the efficacy of herbicides. So I don't know which one, but yeah, happy to chat more about that. And so that's an issue with other chemicals too applied to production systems.
Okay, well, great discussion, and thank you everyone who contributed to that, and thank you, Justine, for starting our year off so well for SNOC, and thank you all for attending and listening, those ones of you that hung in right to the end, and look out for the invitation to next month's SNOC webinar if you're a subscriber. Thanks again, everyone.